Good afternoon. Last week we studied measures of dispersion, measures of location. Then today I will start the probability. Okay? Do you know about the probability concept? Do you know about the probability? No. Okay. Then first, in here probability two parts there. Okay. Then first part, we will discuss what is the probability, what are the basic concepts in the probability. Okay. First, we move into what is the probability. Okay. What is the probability? Okay. Then normally we can say in the statistics subject always we take the numerical variables quantitative. Okay. Then probability we can say it provides the numerical measurement, okay, about the uncertainty. Uncertainty means not 100% sure. Okay. Probability provides a numerical measure of uncertainty. And these are the examples. First one, there is a 30% chance that this job will not be finished in time. There is a chance, 30%, not the 100. Okay. There is every likelihood that the business will make a profit next year. 9 times out of 10, he arrives late for his appointments. Okay, always it mentioned the numerical value, numerical measurement for the uncertainty. It's here. Okay. Then these are the numerical. These are the numerical values we can assign to the probability. Okay, then we starting from 0. Okay, then maximum value plus 1. Okay, then it means we cannot get the negative value to the probability. Okay, always that value should be positive value, but it is less than the 1. Maximum value is 1. Understood? Okay, then impossible, we can assign 0. Certain, it means 100% sure. Then we can assign number 1. Okay. Then it means then always we provide the numerical measures of the uncertainty by fraction or decimals in between 0 and 1. We can assign any values between 0 and plus 1. Understood? Here we cannot get the negative value and the greater than to the plus 1. Understood? Okay. Then the next thing is three-definition perspective of the probability. Okay, then there are 3 perspectives. First one is classical definition of the probability. Other way we can say it's a classical approach. Okay, in the classical approach, we assign the value, okay, based on the theoretical arguments, based on the theory. Okay, then simply we can take the example toss in a coin. Okay, then what are the outcomes we can get toss in a coin? What are the outcomes? Head or tail. Okay, then what is the probability we can get the head? What is the probability? 50% of 1 over 2. Then how we decide that probability value? Right, there are 2 outcomes. Okay, this one outcome is there. Okay, then 2 outcomes are there. Okay, this is one of the outcomes. Then we can say 50% or half or 0.5. Okay, then it says based on the theory. Okay, then that approach we call as classical approach. Understood? Okay. If the process that generates the outcome is known, probabilities can be deducted from theoretical argument. Based on the theories, we can provide the values to the uncertainty. It's here. Then rolling the dice, 10. And get the 6 numbers. Okay, then probability of getting number 1, we can say 1 over 6. Right? These outcomes are there. 1 is 1 time in. Is it clear? Okay. Then it means in the classical approach, normally we do not conduct the experiment to identify the probability value. It's clear? We do not need to do the experiment. Why? Already we know based on the theories the probability value. Okay. Then second one is relative frequency definition of the probability. Relative frequency. Okay. Then here always we provide the probability value based on the empirical data. It means based on the results from the experiment. Okay, here we should do the experiment. Okay, then looking at the results of the experiment, after that we can say this is the probability. It's here, then always we should conduct the experiment to get the probability under the relative frequency approach. It's clear? Okay, then experiment is normally we can see it's a process. Okay, then always we do it the repeatability of the some process. We do the process is repeated, not the one. Clear? අපේ process එක එකපාරක් කරලා බෑ ඒක repeatedly කරන්න ඕනේ probability එක කියන්න. Clear? Okay. It depends on the repeatability of some process or ability to count number of repetitions and number of times that the event of each result. It always based on the empirical data. It means results from the experiment. It's clear. Otherwise, we can say it is based on the repeatability of some process. We take the example in the production process. Last step is check the quality level. Okay, then checking the quality level, we can identify how many defective items are there. Okay, then first step, then we take the only 10 items and find out how many defective items are there. Okay, then after the checking, we found 2 items. 10 items we selected, only 2 items are defective. And then what is the probability here? Getting a defective items? How we say? Then in here, we select 10 items. Okay, then out of these 10, 2 items were found as a defective one. 2 items are defective. And then what is the probability? 2 over, okay, simply we can say 2 over 10. Or other way we can say 0.2. Okay, then next time, we take 50 items. Then out of these 50, 5 items are defective. Okay, then what is the probability now? What is the probability? 0.5 over 50 means 1 over 10, 0.1. Okay, then we take the 100 items. Nine defective items are there. Then what is probability? 0.09. Okay. Then we take the 200 items. Then we find 20 are defective. It means 0.1. Okay. Then next time we identify, we get the 250. Then 25 are defective. It also 0.1. Okay, then next time we get the 300, then 30 are defective, it means 0.1. Now what happened? Probability value approximately is equal to 1. And then based on that, we can say effective rate is 10%. Therefore, we should run the Then therefore we can get the probability value based on the repeatability of the process. We run the test repeatedly, then we can find out the approximately what is the probability value. It's clear? Okay. Then the third approach is subjective approach. Okay. Subjective. Then in here, we get the probability value based on the judgment or experience or knowledge. Okay, then take the same example, we need to find out the defective rate. Okay, then first we meet the quality supervisor and ask from him what is the defective rate. Based on his knowledge and the experience, he can say 15% is the probability. That's the defective rate. Okay, then next time we meet the quality inspection, there is a manager, then he or she say 20% is the probability there. And then it is based on his or her experience or knowledge or judgment. Understood? In the subjective approach means that it is derived from the individual personal judgment or own experience. Okay, then that probability value is different people to people. It's clear? Okay, then other two is not. Another two, classical approach and the relative frequency approach, always we can get the same answer. Right? First one is based on the theory, second one is based on the experimental side. It's clear? And then these are the three types of approach. Next, we move into what are the basic concepts in the probability. And then these are the words normally used in the probability concepts. First thing is we need to identify what is the experiment. Okay, experiment. Experiment means normally we can say it is a process. Okay, then why we conduct the process? Get the outcome. You always see what kind of a result. Okay, then experiment is a process that results in an outcome. Tossing a coin, rolling a dice, all are the experiments. Is there? Then other word in here, outcome. What is the outcome? Outcome means are the results that we observe. Okay, then rolling a dice, we can observe 1 to 6 numbers. These are the outcomes. Okay, then tossing a coin, we can get head or tail. These are the outcomes in. Is there? Okay. The next one is what is the random experiment? Normally we conduct the random experiment. It means in the random experiment is also the repeatable process. Here we know what are the outcomes we can get, but we cannot predict which outcome now we can get. It means then tossing a coin, we know head or tail we can get, but we do not predict which outcome now we can get. Understood? Then that we call as a random experiment. Rolling a dice, already we know 1 to 6 numbers we can get. Any number in between 1 to 6. But we cannot predict which outcome, which number now we can get. It's clear? That a kind of experiment we call as random experiment. It's clear? Okay. Then other one is we conduct the experiment. Okay. Then we can get the results. These results we call as outcomes. Okay. Then we go into the sample space and the sample points. Sample space means all the possible outcomes of the random experiment. All the possible outcomes. Okay. Then tossing a coin, we can say head and the tail. Rolling a dice 1 to 6 now. It's clear? Okay, then we take all the possible outcomes. It's clear? Okay, then normally we denoted by sample space is letter S. Okay, then equal sign. Okay, then open the curly bracket. We can mention what are the outcomes in here. Head and the tail. This we call as sample space. It consists all the possible outcomes. Understood? Then other thing is, In here, two outcomes, no? Then one outcome we called as sample points. Sample points. Then here, how many sample points? 2. Here, rolling a dice, how many sample points? 6. 2. Okay. Then tell me, then toss in a 1 coin. We can get 2 sample points. Okay. Then toss in a 2 coins. How many sample points? Toss in a 2 coins. How many sample points we can get? How many? Toss in a 2 coins. How many sample points we can get? Toss in a 2 coin means first time we can get both 2 heads, okay, or we can get 2 tails. First time head, second time tail. First time tail, second time. Okay, how many sample points? Then toss in a 3 coins. How many? It's only 2 sample points. Okay, then toss in a 3 coins. Eight outcomes. Toss in a 3 coins now, 3 heads, 3 tails, 2 heads and 1 tail. Okay, 1 head and 2 tails. Then how many? Then there are 8. It means then initially we have 2 sample points now. Okay. Then the toss in a 1 coin, it means 2 to the power 1. Toss in a 2 coins, 2 to the power 2. Toss in a 3 coins, 2 to the power. Understood? Then toss in a 10 coins, we have sample points 2 to the power 10. It's clear? Understood? Sure. Then here example, in a throwing a die, the sample space is 1 to 6 numbers. It means 6 possible outcomes are there. Then second one says, in throwing a 2 dice, the sample space. 2 dice means how many sample points? 6 to the power 2. Why? Basic 6 sample points are there. Dice means 6 to the power 2. 36 outcomes are there. Then these are the 36 outcomes. It's clear? Okay. Then we move into the events. Event means any collection of the possible outcomes. And then it means we take the rolling a dice, we can write sample spaces 1 to 6 numbers. Okay, then we take the collection of outcomes in here. We say it's an event. Normally, the event is denoted by capital English letters. Okay, then we say event A is the getting an even number. Okay, then what are the outcomes? Getting an even number 2, 4, 6. Then it is a collection of the outcomes. Then this is the event. Understood? Getting an odd number, then getting a prime number, getting a number which is less than the number 4. It means 1, 2, 3. Okay, then we write any collection of the outcomes we call as event. It's clear? Then Next one is what are the rules of operation? Now you know what is the event, what is the sample space, what is the sample points, okay? You know intersection, union, complement. Yes or no? Hey there. No. Okay. Then first operation is intersection of the events. Intersection. Intersection means common area. Okay, common. Here. Then here, you know Venn diagram. Here then there is a rectangular shape. That shape represents the whole sample space. This rectangular shape represents the sample space. Okay. Then using the circle denoted events. Okay. Then in here event A and event B. Okay. Then the intersection we write here. Then two events are there, A and B. Then we write in here A intersection B. Okay. Then intersection means common. Then this is the area common to the both event A and event B. Clear? This is the way we can represent the intersection using the Venn diagram. Common. It's clear? Then we take the example. Sample space is 1 to 6 numbers. A is odd numbers. First event. Second event is numbers less than 4. Okay. Then first event is odd numbers now. Then we identify what are the outcomes in here. 1, 3, 5. Odd numbers. Okay. B, numbers less than 4. It means 1, 2, 3. Then looking at these two events, are there any common elements? What are the common elements in here? 1 and 3. It's clear? Okay. Then 1 and 3 are the elements in the intersection. Intersection B is 1 and 3. Now clear? Intersection B is common. It's clear? Then we move into the next one. Union. Union means we take the two events. Okay, then we need to get the probability or outcomes of the union of these two events. It means all the elements in the both events. All the elements, not the common. Clear? All. Then in here, the circle represents event A and event B. Okay? Then in here, union means what? All the elements. We can cover all the elements. It's clear? Oh. Then here, take the example. Sample space is 1 to 6 numbers. A is odd numbers. B is numbers less than 4. Previous example. Here, then we take outcomes. We can write all elements in the event A and event B. It's clear? Then there is same outcomes of 1 and 3. We write only one time each outcomes. It's clear? Then what are all the outcomes? 1, 2, 3, 5. It is the union. It's clear? The union means all. Intersection means both. Common. Okay, then in here union, normally we use the word or. A union B means A or B. A or B means event A, we can get event B and both. Understood? Intersection means A intersection B means and. Word is and. And A and B. Both. How? It's clear? Next one is complement. In here, they normally complement. Then we need to find out the complement of A. We write A dash. Here we say A dash, complement of A. Okay, then it means it consists elements in the sample space, but these elements are not included in the event. A complement. These elements normally in the sample space, but these elements are not included in the event. Then here, event A means 1, 3, 5. These are the elements. Then what are the other remaining elements in the sample space? 2, 4, and 6. Then A dash or complement of A dash means 2, 4, 6. Complete. It's here. Then these three elements are in the sample space, but these elements are not included in this event. It's clear? Okay. Then tell me how we write it. What is this? Complement of the A union B. Complement of A union B. It's clear? It means these elements should be in the sample space, but not in the union. Then A union B means all the elements in the A and B. What are the elements? A union B in here. 1, 2, 3, and 5. Here, take these 2, 1, 2, 3, and 5. Then, what are the elements in the complement? 4 and 6. Remaining elements. Here, we can say 4 and 6. It's here. Okay, understood? Then, here, tell me the outcomes in the complement of A dash, A intersection B. First, we identify what are the elements in the intersection. Okay, then tell me what are the elements in the intersection. 1 and 3. Then what are the other elements? 2, 4, 5, 6. Now clear? Complement is okay now. Then how we write this one? A dash intersection B. It means what? Then first we write down what are the elements in the A dash. A dash means what? 2, 4, 6. Then what are the elements in the B? 1, 2, 3. It's clear. A dash means 2, 4, 6. B means 1, 2, 3. Then what is the sign in here? Intersection. Intersection means what? Common. Then what are the elements in the common in here? 2. Then what is the answer? It's clear. Then tell me, then in here A dash, this is the event B. Okay. Then answer is 2. It's 2. Okay. Then A dash we find out using the event A. No? Okay. Then A dash we get from the event A. Then looking at the event A and event B, then 2 is in only event B. Here there is no any 2, only is there. Understood? It means A dash intersection B means, another meaning we can say only B. B only. Looking at the A and B, okay, 2 is only in the event B. It's clear? Then other way we can say outcomes only in the event B. It's clear? Then next one. B dash intersection A means what? B dash intersection A means what? A only. It's here A only. Then we can say A only. It's here. Okay, here we can say B only. This is the A only. Understood? The next one is collectively exhaustive events. Okay? Collectively exhaustive events. Collectively exhaustive events. Okay. Then looking at this example, not this, then we take the another example. A is getting an even number. No, sorry. We take getting an even number. The elements is 2. Outcomes are 2, 4, 6. Then we take the event B. Event B means numbers, these numbers less than to the 6. Okay, when it consists the numbers, but all the numbers are less than to the number 6. Then what are the elements? 1, 2, 3, 4, 5. Okay. Then in here, what is the A union B? What are the elements in the A union B? Union means all. Then what are the elements? 1, 2, then here 3, then 4, 5, and here 6. Now what happened? In the union, it consists 1 to 6 numbers and the sample space 1 to 6 numbers. It's here. Then it means in here A union B is equal to the sample space. Okay, A union B it consists 6 outcomes, 1 to 6 numbers. Then this element is equal to the elements in the sample space. It means it covers whole sample space. It's clear? Then we can say event A and event B are collectively exhaustive events. Understood? We consider in the 2 or more events that covers whole sample space. We call as collectively exhaustive. It's clear? Then it means when we draw the Venn diagram, event A and event B, there is no any elements outside these 2 circles. All the elements are inside the 2 circles. Then here, this one is 2 is common, 4 is common, here 6, then others are 1, 3, 5. In here, no elements are there. It means the union of these 2 events cover whole sample space. It's there. Okay, then we call it as collectively exhaustive events. Understood? The next word is mutually exclusive. It means when we take the example, rolling a dice, 1 to 6 numbers, A is getting odd number, B is the getting an even numbers. Okay, then event A is 1, 3, 5. Event B is 2, 4, 6. Okay, then tell me, are there any common elements? Now, are there any common elements? No. A include 1, 3, 5, B is 2, 4, 6. It means A and B are mutually exclusive. It means there is no any intersection. There is no any elements in the intersection. Okay, then we can say A. This is no here. A intersection B, there is no any elements. Okay. Understood? Then when we draw the Venn diagram, we can draw these two events separately. Why? No common elements in here. There is no any intersection. Understood? We call it as mutually exclusive. It's clear? Okay. The last point is equally likely events. It means the outcomes of a random experiment are said to be equally likely if, after taking into consideration all the relevant evidences, there is no reason to expect one in preference to the other. Rolling a dice, 1 to 6 numbers is there. Getting a number 1, probability is 1 over 6. Okay. Then getting a number 2, again 1 over 6. Getting a number 3, 1 over 6. It means these elements are equally likely. Same possibilities are there. Getting a head, 1 over 2. Getting a tail, 1 over 2. It's here. Okay. Then other way, how we write the probability value, normally we can express as the decimal value or the fraction. Okay. In the fraction, normally it consists numerator and denominator. Okay, then here is the numerator. This is the denominator. Denominator represents the total number of equally likely cases. It means how many sample points in the sample space. It's clear? Numerator represents the number of favorable cases. It means rolling a dice, total sample point 6. Okay. 3 even numbers are there. Then we can say getting an even number, probability is 3 over 6. It's clear? Then the last one, the theorems we can use in the probability curves. Theorems. Okay? Then we move into that. Then first one is we take the Venn diagram. There are two events, events A and B. Events A and B. Okay? Then we need to find out probability of A union B. Okay? Then here A union B means all the elements in the event A and event B. All. It's clear? All. Okay? Then A union B. Then first we take this circle. What is it? Probability of A. Event A. Then we take probability of A. Okay? Then we consider the next circle. It is the probability of B. It's clear? Then there is a common area, intersection is there. Now what happened? Probability A plus probability B. Then what happened? Then we take this circle and this circle, then this common area add twice. By common, then that common area is consisting in event A and event B both. Then we in here add them twice. Add it twice. Therefore, we deduct one intersection from the addition. Okay, then probability of A plus probability of B minus intersection. Yes, sir? A sorry.
It's not intersection, union, yeah.
You have any questions, Buddha? Sorry, there is here. Okay, it's a mistake. Then we need to find out the A union B. Okay, then here probability of A plus probability of B. These two events add them together. Then we added twice the intersection part, common area. Therefore, we deduct intersection from the addition. It's clear? This one we called as additional law of probability. We call it additional law of probability. Okay, then using this formula, you can find the union value, intersection value for those. Clear? Then other one is two events are mutually exclusive. It means what? Now you study. Mutually exclusive means what? Yeah, there will be no common elements. It means no intersection. If the two events are mutually exclusive, two events are mutually exclusive, how we get the union? We take probability of A plus probability of B. On why there is no intersection. Therefore, we do not need to subtract the intersection from this addition of these two values. Understood? Why mutually exclusive means there are two circles, but these two are separate. There is no any common area. Then we can take the circle plus this. It's clear? Okay? Then other one is tell me what is it? Now you know. A dash intersection B means what? A dash intersection B means what? B only. Then how we find out the B only? Probability value. How we get it? Then we take the A and B. We need to get the B only. Okay, B only means this way. B only. This part is common to the both A and B. It's clear? Then how we get the B only? We take the whole circle, then remove this common A. Understood? Then this whole circle means what? Probability of B. Probability of B is the whole circle. Then here we need to remove this common area. Common means what? Intersection. Then probability of B minus intersection. It's clear? Okay, then the B only means B, then we subtract the intersection. Then we need to find out the A only, then we take the probability of A, then remove the intersection. It's clear? Okay. Then other one is, then what is this? What is this? A dash intersection B dash. Which is A dash intersection B dash. Then normally A dash intersection B dash. Okay, then easy way we can find it. Okay, then there is a law, Morgan law. We call it Morgan law. Here, the dash complement is common to the both event. The common one. Then we take this in this complement sign is outside the brackets. Okay. Then we write the two events A, B. Okay. Then change in the operation in here. This event operation is intersection. What is the opposite one? Union. Then we write in here. This is equal to the what? Complement of the union. Complement of the union. It's clear? Okay. Then here we take A dash union B dash. What is it? A dash union B dash means what? Only change in the sign in here. There is a union. Then we take the intersection. It means complement of the intersection. This is equal to the A intersection B dash. It's clear? Then using the Morgan law, we can find it easy. Okay, then here normally this one says A dash intersection B dash. No? It means then we take the Venn diagram. This circle is A, this circle is B. Okay, then first one is A dash. No, A dash means all other remaining area. A dash. Okay. Then other one is B dash. Okay. Then excluding B, all other. Okay. Two ways are there, A dash and the B dash. The sign is what? Intersection. Intersection means what? Common. Then which area is common to the both A dash and B dash? Which area? Outside. This one, white, black, and the red goes in here. Okay. Then it means what? Complement of the union. Why these two circles represent the union? Outside these two circles means complement of the union. Clear? Okay, then this is the probability part one. Okay, then the simple concepts in the probability. Okay, then first we study what is the probability. Okay, then probability is a numerical measure of uncertainty. Okay, then we define different concepts in the probability. What is the what is the experiment? Okay, then experiment is a process. Okay, then we want to get some outcomes. Okay, using the experiment. Then outcomes means what are the results we can observe in the experiment. Okay, then we identify what is the sample space and sample point. Okay, then we move into the rules of operations. Okay, then after that we studied how we write down the probability values. Okay, you can use in the fraction or decimal. It's here. Then we move into the worksheet. Question number 1 is then start the question number 3. And hurry up. It's very easy one. Then try question number 3. ඒක මෙහෙලනේ අර stop sharing and screen මොකද ඒක? ඒක ඊට මෙන්න දාගන්න බැරිද? ඒක ඇත්තට යන්නේ හරි. Thank you. Finish? Then here the results of an examination conducted in two parts, 1 and 2, for 50 candidates were recorded as follows. The total candidates 50. 20 passed in part 1, 15 passed in part 2, 18 failed in both part 1 and part 2. This is the story. Then first we identify what are the events in here. Then we can take event A is passed. Part 1. Okay, then we take next event, event B. Event B is passed. Part. Okay, then what is the probability of probability of A is how many students passed part 1? 20. Then it means 20 over 50. Yeah, first information is Then passed in part 2, what is the probability? How many students passed part 2? 15. 15 over 50. Okay. Then other one says what? 18 students failed both parts, part 1 and part 2. Event A and event B says the partial rate, pass part 1 or pass part 2. And then 18 students failed both parts. It means what? A means pass, no? Then fail means A dash. Okay. Then we can take fail, part B fail, B dash. Both parts fail means what is the event operation in here? Intersection, both. Okay. Then what is the answer? 18 over 50. Okay. Then this one, how we write? Other way. A dash intersection B dash equal to 18 over 50. Then other way, how we write? Using the Morgan law, we can write A union B dash is equal to 18 over 50. It's clear? Okay. Then what is the question number 1, Master? What is the question number 1? Question 1 passed in both part 1 and part 2. Okay, then both means intersection. It means question number 1 asks probability of A intersection. Okay, then how we find out the intersection? We can use the additional law of probability. Okay, then using this formula, additional law of probability means A union B equal probability of A plus probability of B minus intersection. Question asked to find it that one. Both parts, no, it means intersection. Then what is the union value in here? Union is, what is the probability of union? Union, no. Complement of union is 18 over 50. Then what is the union? 32 over 50. Remaining parts. Okay. Then union is 32 over 50. Okay. Then probability of A is 20 over 50. Then plus B is 15. Then we can get the value of A intersection B. Okay. Then we decide A intersection B. Then it means 20 plus 15 minus this value 32. What is the intersection? 3 over 50. Here, okay. It means 3 students passed in both parts, A and B. It's clear? Okay. Then go to the next one. Okay, so we go into the next part. Failed only in part one. Failed only in part one. How we do? Failed only in part one. Then how we write? Failed only part one. It means what? Failed only in part one means what? Failed only part one. In other way, how we do? Only B means what? The students passed only part two. Failed in only part one means the students passed only part two. It means what? B only. Okay, then how we write the B only? A dash intersection. Okay, A dash intersection B only. Then we take the B. Then remove intersection. Okay. Then probability of B is 15. Then minus intersection is 3. What is the answer? 12 over 50. Here, it means 12 candidates passed only part 2. 15 students passed part 2, but 3 students passed both parts. Therefore, 12 candidates only passed in part. It's clear? Then the third point, C. Failed in only one of the parts. It means what? Failed only in one of the parts. Failed only in one of the parts. What is it? These candidates only failed one part. It means passed only in part 1. Other one is passed only in part. Clear? Okay, one of the part is passed. Passed or failed. Sorry, failed. Sorry, failed. No? Okay, failed. Failed only one of the parts. It means failed only part 1 means these candidates passed part 2 only. Okay, then failed on part 2 means these candidates passed only part 1. It means A only plus B only. Yes. Then A only plus B only. Here, one of the part is failed. Or we can say one of the part is passed. Okay. Then here, A only, A is 20 now, then 50, 20 over 50 minus intersection 3. Okay. Then plus B only, B is 15, then minus intersection. Then answer is 29 over here. Okay, understood? Then do question number 4. Here, it is there. Then it's not the A, no B, we love. Neither A nor B, we love. One word. Shall we discuss? Then here, probability of A equals 0.39, B 21, A union B is 0.47. Probability of A 0.39. Probability of B is 2. Then the other one is union. Questions. Union is 47. Okay. Then this one asks neither A nor B will occur. It means what? Neither A nor B will occur. Then B. Neither A nor B will occur in what? Neither A nor B will occur. Supplement of A union B. By A union B means A or B will occur. A or B will occur means union. O means all. Then neither A nor B will occur means what? Complement of the A union A. How we get the complement? 1 minus y total probability value is 1. Total probability is all sample space. Then it is equal to 1. Then minus union value. The answer is 0.53. It's clear? Okay. Then what is the next question? Both A and B will occur. Both A and B means what? Both mean intersection. probability of A intersection B. Okay, then we know the union value 47. Okay, then take the union value. Then we can deduct probability of A plus probability of other way. Logger. Only thing we can use it is additional law of probability, get the value. Probability of B minus the intersection. Okay. Then union is 47. Then here 0.39 plus 0.21. Okay, then we take intersection here. Then how we get the answer? 0.39 plus 0.21, 0.6. Then we need to deduct 0.47. Intersection is 0.13. Okay. The next one is only AB logger. Okay, part C asks only AB logger. It means A only. It means A intersection B dash. A only. Okay. Then the probability of A is 0.39. Then deduct the intersection 0.13. What is the probability of A only? 0.26. Here, you can take a break. After the break, we will discuss the questions and start the next part. Okay.
Individual. 2 weeks.
Then do question number 5 and 6. Okay. Question number 5. Probability of A equals 0.4, probability of B equals 0.3. A and B are mutually exclusive. Find the A of A. Probability of A and probability of B is given. Question asks A or B. It means A union. Okay. Then probability of A is 0.4, B is 0.3. Other says these two events are mutually exclusive. It means there is no intersection. And then how we get union? probability of A plus probability of B. Then 0.4 plus 0.7. Then answer is 0.3 no? 0.7 is the answer. 0.4 plus 0.3 answer is 0.6. If the two events are mutually exclusive, it means there is too many intersections. The next one, if the probability of A equals 0.7, B equals 0.2, union is 0.9, are A and B mutually exclusive? Question asks, check whether A and B are mutually exclusive. Okay, then if A is 0.7, 0.2, probability A is 0.7, probability of B is equal to 0.2, then the A union B equal 0.9. Okay. Then here A and B add them together. What is the answer? 0.9. Okay. Then it is equal to the A union B. It means A and B are mutually exclusive. Intersection is 0. Clear? Okay. Then try question number 8. 8. Number 22. Number 22. Number 26. 3, 4, 5, 6, 7, 8, 9.
Hello, madam.
Yes. Yes.
My number is 27.
No, Buddha. Then only check the physical class. Okay.
Okay.
This is the number 5. Number 4 is 5. 5. 6. No. Let's check the number next. Number 6. Absana. Your name? Then number 7. 8, 9, 11, 12, 17, 19, 21, 22, 23, 26, 28, 29, 30, 31, 32, 69, now tell me your problem. My problem is there is not a bad because yes, there's a good to guys not in finish. Shall we check question number 8? 8 cards are in a box. The cards are numbered 1 through 8. Okay? Respectively, the cards numbered 1, 2, 3, 4, 5 are blue, and the cards numbered 6, 7, 8 are red. And then there are 8 cards. Okay, then each card is numbered. First 5 cards are in the blue color. Then the 6, 7, 8 numbered cards are red color. A single card is drawn from the box at random. Find the following probabilities. First one, probability of card is a number 2. How many cards is there? No, in here, the card number is number 2. Then how many cards? Only 1 card is there. Okay, then total number of cards in here, 8. Then what's the probability? 1 over 8. Then next one, probability of card is a 2 or red. It means what? Then if we select the card, then number is 2 or red color card. How many red color card? 3, no? 6, 7, 8. Okay? Only one number 2 card is there. Then altogether, how many? There is no any common elements. Then we can write 4 over 8 for the answer. Here, then the probability of card is blue and odd number. And means what? It means common. Then card is blue and the odd number. Then we identify blue card is this. This is the blue card. Okay, 1, 2, 3, 4, 5. Okay, then card is blue or odd numbers. In here, how many odd numbers are there? 3. Then what's the probability? 3 over 8. 35.
3 over 5. 3 over 5.
3 over 8 put up. Then here card is blue and the odd numbers. Then how many blue cards are there? 5. Then it means 5 over 8. Then plus, okay, then odd numbers. Then in here 1 to 6, 1 to 8 numbers are there. Then how many odd numbers? 1, 2, 3, 4. Then 8 over 4. Okay. Then we need to subtract common elements. It means blue and the odd number. Then how many? I'm sorry, in here add no. Sorry. No need to take the union or intersection. Then here there are 8 cards are there. Then you need to select how many cards are there, blue color and the odd number. Blue and the odd number. Then these 3 cards are red color. No, we cannot take. Blue and the odd numbers. Then here 1, 3, 5 are odd numbers and the blue color. Then we take the 3 over 8. Okay. It's clear, not the 5. Okay. Then here D1, the card is blue or odd number. Blue or odd number. How we get it? O means union. Then how we finding the union? How we finding the union in here? First identify how many blue cards are there. How many? 5. Okay. 5 blue cards are there. Here, how many odd numbers? 1, 3, 5 and 7, 4. Then we need to deduct intersection. It means blue and odd number. How many? 3. Then what is the union? 6 over 8. And the answer for the part E. Probability of part is odd or even. And the probability odd or even. Odd or even 8 over 8. Then probability is 1. Yeah, right. Then odd or even means these two events are collectively exhausting. Here 1 to 8 numbers are there. 2, 4, 6, 8 even numbers. 1, 3, 5, 7 odd numbers. Here I write all the animals, it covers the sample space in this question. Here, then the last one answer is 1. I will give 5 minutes. If you have any questions regarding the probability, then ask from me. Then after that, we will start the next one. Have any questions? You ask.
Miss, can you explain again D?
Which one, Buddha?
Hello, Miss.
Yes,
D,
Buddha.
D, can you explain again it? D?
This one.
Yes, this one, yes.
Okay. Here, Buddha, then the card is blue or odd numbers, no? Yes, then here, section asks blue or odd numbers. Okay, O means union. O means union. Okay, then here 5 blue color cards. Okay, then odd numbers 4 is there. Right, 1 to 8 numbers, no? Then 1, 3, 5 and 7 are the odd numbers. Okay, then the five blue color cards are there. Then normally how we find the union? Then here we can say, we can use in the additional law of probability. Probability of A plus probability of B minus intersection. Okay, then we put card is a blue, we say event A, card is an odd number, event B. Then probability of A, then 5 blue cards, you know, then we can say 5 over 8. Then plus, event B says odd numbers, then there are 4 odd numbers, then 4 over 8. Then intersection means, in here, blue card, 1, 2, 3, 4, 5 numbers. No? 1, 2, 3, 4, 5. These cards are blue. Then we need to find out the intersection. Blue card and the odd numbers. Here, 3 odd numbers. Therefore, we deduct 3 over 8. Then answer is 6 over 8. It's clear?
Yes, Miss, it's clear. Thank you.
Okay. No issues. Shall we move to the next part? In here, first we will study joint probability and the marginal probability. Joint and the marginal probability. Now stop talking. Joint probability means, using the joint probability concept, we find out the joint occurrence of two or more joint occurrence. Okay, then we take this example here. This is the BSAA contingency table. You studied in third chapter. Okay, presentation of categorical data. Okay, then if we have more than one categorical variable, we use the cross tabulation or contingency table. Therefore, this table we call as contingency table. Okay. This table shows the results of a hypothetical survey in the 10,000 individuals were asked whether they favored increased defense spending. 10,000 persons classified by attitude towards increased defense spending and their political party. Okay, then this table shows two categorical variables. One is their political party, other one is their attitude. Okay, understood? Then, in the joint probability, we take the example. Read the first part, first one. If a person is chosen at random from this group of 10,000, there's probability that he or she is a Democrat and favors increased defense spending. Okay? Two things are there. Okay, what is it mentioned their political party and their attitude both. Okay, Democrat and favors increased defense spending both. Then how many? Democrat and favors increased defense spending. Okay, and means intersection of common. Then how many? How many? What is the joint? 2,500. 2,500 individuals. Their political party is Democrat and favors increased defense spending. How many? 10,000 are there. Then it means what is the probability? 2,500 over 10,000. Understood? Here then always in the joint probability concept we discussed about the two events. Okay, then these two events occur simultaneously together. It's their political party and their attitude both. Okay, then other way we can say randomly selected person is a Republican and he or she does not favor increased defense spending. Their political party is Republican, then does not favor increased defense spending. Okay, then it means how many? 1,500 individuals are there. Understood? Okay, it's clear. This we called as a joint probability. There is two events. These two events occur simultaneously. It's clear? Okay, then in the joint probability concept, always we discuss about the joint occurrence of two or more events. Not only the two events, we can discuss with the three or four events. It's clear? The next concept in here, marginal probability. Joint probability means joint occurrence. No? Okay. In the marginal probability, we find in the probability of the single event. It means, take the previous example, then we find out the probability of the selected person is a Republican. Only we discuss about the one event. This we call as marginal probability. It's clear? Or we can say, if we randomly select the one person, he or she does not favor increased defense spending. Only we discuss about the one event. We take the probability value of the single specific characteristic. It's here in the joint probability concept we discuss two or more events and find out the joint occurrence. It's clear. Then here finding the probability value of the single specific characteristic. Then marginal probability that a randomly chosen person favors increased defense spending. The statement is discussed about only their attitude. Okay? If they are just favors increased defense spending, then looking at how many favors increased defense spending. How many? 5,000. This statement only discuss about their attitude. Then attitude is favors increase defense spending. It's clear? Okay, then how many? 5,000. The probability value is 5,000 over 10,000. Okay, then we take the example, if we select a randomly person, that person's political party is Democrats. We are only discussing about their political party, not their attitude. Then the Democrat, then how many? 6,000. Probability value is 6,000 over 10. It's clear? Okay, then these are the two different approaches, joint probability and the marginal probability. If we need to find out the joint occurrence, we use joint probability concept. If we need to find out the probability of the single characteristic, single specific characteristic, we use the marginal probability. It's clear? In this worksheet, first question, it gives the cross tabulation and asks the 3 questions, okay? Up to that point, only you can answer the first part and second. Hurry up. First read the table, then write the answer for the Roman number 1 and 2. These two. Roman number 1 and 2. I uploaded that to the LMS, okay? Let's be downloading from the environment. Side minutes. Suppose a study of speeding violations and drivers who use cell phones produce the following fictional data. Okay? Then first variable is cell phone user or non cell phone user. Then the second variable in here, speeding violation. Then that the person had no speeding violation or had speeding violation. Okay? First one asks, find the probability that a person is a cell phone user. You can ask to find out the probability value that the selected person is a cell phone user. They tell me it is about the marginal probability or the joint probability. Marginal probability.
Marginal probability.
Okay, then why it is discussed about only one variable, one event in here. Okay, then what is the answer? How many cell phone users are there? 300 and the total value? Okay, then answer is 305 over 755. Okay, then second one, Find the probability that a person had no violation in the last year and was a cell phone use. We discuss about the two scenarios, okay, two events, and then there is a word and. Then it means these two events occur simultaneously. It means joint probability occurs. Then had no violation, it means this one, and the cell phone use. Then how many? 280. Then answer is 280 over 750. Clear the joint probability concept and the marginal probability concept. Okay. The next one is additional probability concept. Then we study what are independent events. Then after that we will discuss total probability rule and the Bayes rule. And then we will discuss these four concepts in the next week. Then another one is you have to do the 3 assignments. 30% mark allocated to the assignment, CA component, continuous assignments. So I will upload the assignment 1 to the LMS in the next week. Okay. Then 1 week is enough. 3 assignments are there. The 10 lectures, then this is 50. Only 1 week enough. Okay, then I will upload the assignment to the LMS. Okay, within time period, you do that and scan it. After that, you can upload it to the LMS. Okay.